Hello, everyone. I am the closing act for today. My name is Anita Singh. I am based out of San Francisco, where I work for a startup called Winnie, which is an app for parents. And today, I'm super excited to be here to talk to you about fonts and emoji using the support libraries. Of course, the support library is now repackaged as Android X and is part of Jetpack. So this talk will refer to dependencies from both. And this is the 360 and dev version of this talk, so basically the best version. And today I'm going to cover changes that were introduced in Support Library 26. So we're going to learn how to use custom fonts using fonts in XML and downloadable fonts. And we're going to learn how to future-proof your emojis using Emoji Compat. So let's get started. So fonts in XML has made it really convenient for us to use custom fonts in our app. What is it? You can now create a font resource, a font directory, and put it under res, and put your custom.ttf font files in there, and then you can refer to it like you would for any resource type with r.font.font name or @font/font name. So now you can refer to fonts in your layout files, which is really convenient. Another type of file you can add to the font resource directory is a fontFamily file. And this essentially sets up the relationship between different text styles, font weights, and fonts. So typically when you use a font, in this example, I'm going to be using Lato, which is a Google font. There are typically a lot of different weights. There's Lato Black, Lato Semi-Bold, Lato Bold, Lato Italic, and you really don't want to use 6 different types of Lato all throughout your layout file. So you can put them in the fontFamily files and set up the relationship between the weight and the style. So when you do text style equal to bold, it will pick the correct font based on this file. So that is also a pretty convenient addition to Android. But why do we need it? We've come so long without it, right? Well, if you've ever used custom fonts before, you've probably used a third-party library like calligraphy or font binding, or you do something like this, where you have a custom text view, and all that you're doing in this custom text view is setting the typeface in the constructor. And then you're using this custom text view all throughout your app if you want your app to have a consistent custom font. And that's not fun. That's a lot of drama just to use a custom font. And now, luckily, Android has shown fonts some love, and we don't need to do this anymore. But how does it work? It works using basically AAPT and AppCompat magic, where AAPT stands for the Android Asset Packaging Tool. So when you compile with SDK 26 and above, it uses Android Oreo's version of AAPT, which understands fonts and is able to bundle them into resource files. And then the support library is able to read the attributes from these resource files through the AppCompat layout inflation process. So what we have here is a beautiful, beautiful stack trace. Of course, as developers, we love our stack traces. But the reason I put this here is because you can see exactly what's going on right from when you do set content view. So when you do set content view, it goes up to layout inflator, goes to AppCompat delegate, all the way to the top at typeface compat API, or typeface compat. And typeface compat has different implementations based on different OS versions. So you have typeface compat API 26, 21, and these essentially contain the code to load a typeface for you from a font resource file. So it's essentially using AAPT and this AppCompat layout inflation process that Android was able to add a new resource type and have it be backwards compatible, which is pretty cool. So how do we use it? There is a handy fontFamily tag that you can use, and it can either refer to a font family or just a custom font, up to you. And this next part is my favorite. Now, if you want all the text views in your app to have the same custom font, all you have to do is, boom, one line of XML in your app theme, and all the all the text views in your app will have this font. No more custom text views, no more third-party library dependencies just to use custom fonts. So this is a pretty big improvement from Android. And of course, there is an API that you can use for custom fonts, namely resources-compat.getFont, if you want to set it programmatically. It is an Android development without its gotchas, so you have to make sure to use both the Android and namespace and app namespace in your fontFamily files if you want it to work on Android Oreo above and below. And because this uses the AppCompat layout inflation process, you have to use AppCompat components like AppCompat activities, support fragments, and such. And here's some further reading if you're interested. The next topic, downloadable fonts, also makes it really easy for us to use custom fonts. So what is it? Essentially, apps can now share font files with each other. So different apps can now request a font from a central font provider application using the font contract compat API. And what this font provider does is it looks into the font cache to see if it has the font. If it does, great. If it doesn't, then it simply downloads it from the internet, caches it, and gives it back to whatever apps need it. Something to note that the only publicly available font provider that we know right now is the Google Fonts font provider, and that lives in Google Play Services and has access to over 800 different kinds of fonts, but they're mostly Google fonts. So this is also pretty convenient. So why do we need it? Well, if you use downloadable fonts, you can reduce the size of your app bundle or APK because you do not need to bundle fonts anymore in your app. And these can be large files, like 7 MB plus. And if you have multiple of these, it can be a huge chunk of your APK. And if you reduce the size of your APK, it can have a huge impact on your app install rate. So that's great. And because you can share fonts between apps, this results in saving data, disk space, memory for the user. Because can you imagine how many Roboto font files are on your phone right now? Or Lato, any popular font, your phone has multiple copies of that. It keeps getting downloaded again and again with every app that you install. And if these apps use downloadable fonts, it will save you a lot of disk space, memory, and data. And if your user understood this, what a great benefit you're doing, they would be happy like this blob emoji here with sunshine and rainbows. And we owe it to our users that they feel this way. And so any chance we get, we should try to optimize. So how do we use it? One way is to do it programmatically using the support library. So you set up your font request, you set up where you want the font from, which in this case is gms.fonts, Google Play Services, the font that you want, which in this case is Lato, and then the certificates for security. You can use Android Studio to generate this, and I will be going into that in a bit. And then you set up your callback with the success and failure callbacks, and in the success, you can set your typeface. And then you want to set up a handler because you don't want the font download to happen on the main thread. You don't want to block UI for this. And so you set up a handler to run on the background thread. And then you put it all together with fonts contract compat.request font. And you pass in the font request, the callback, the handler thread. And then when the font is retrieved, either from the cache or the internet, you get one of the callbacks and you can deal with it appropriately. What you just saw is cool, but you probably don't want to do that in every activity, fragment, custom view group, and therefore I recommend that you use Android Studio and fonts in XML instead. So to do it this way, open your layout editor, just select any text view, and select font family from the left, scroll down, select more fonts, then select the Google font that you want to apply from the left, and make sure create a downloadable font is selected. And if you do these steps, 3 files will be downloaded for you. by Android Studio and add it to your project. The first one being lato.xml, which is a font family file that you've seen before, except that the attributes here are for loading it from downloadable fonts, or loading it from a font provider rather than a bundled font. And something worth noting is that there's the font provider fetch strategy, which can either be blocking or async, async being the default. Now you might be looking at this and wondering, why would I ever use blocking? There is a use for it. If you are working with a custom view that's maybe drawing some text and you want it to load the typeface, you can have your custom view implement the font family attribute, and that way you can set the font in XML. However, if you do it with async, the font won't get set, because generally with async, the framework or support library downloads the font and updates the typeface of your text view in asynchronous callbacks. But because the view that you're working with is not a text view, that asynchronous callback will fail. And so blocking fixes that. If you still want to load it asynchronously, you can. You're just going to have to do it programmatically with what I just showed you for your custom view. Another thing, it can also help with debugging. Like, let's say your font is not being set. If you change it to blocking and it fixes it, then that means there might be something wrong with your callbacks. So it's just a tool, just something to be aware of that can be useful. The second file that's downloaded is the font_certs.xml, which prevents us from getting fonts from an unknown source, because that would not be fun. And it contains the certificates for prod and dev environments. And the third file that's downloaded is preloaded-fonts.xml. And this essentially lists the fonts for prefetching. So if you include this, then your app will initiate the download as soon as the app is launched, rather than doing it on first layout pass, because you don't want to see 5 seconds of Roboto and suddenly see your custom font. You want to see your custom font from the get-go. And this helps avoid that. Doesn't guarantee it won't happen, but it reduces the likelihood of that happening substantially. So this is another reason I recommend that you use Android Studio and Fonts in XML, because now the app can pre-launch the fonts for you. This only works if this metadata tag is in your manifest, and Android Studio should have automatically added it, but make sure to check and see it's there. And if you do all of this, you are ready to apply fonts in XML. Again, with just one line of code, one line of XML in your app theme, just like you would apply your regular font to your app. So what are the gotchas? You need to use Android Studio 3.0 if you're going to, and above if you want to generate these font files and the certificates, which I hope you're already using. It's because the only publicly available font provider is in Google Play Services. This will only work in certain versions of Google Play Services and above. Initially, I thought this was a deal breaker, but turns out Google Play does a decent job of making sure Google Play Services is up to date. I think it updates it every 3 weeks or so. However, that being said, there will definitely be users who won't have this version and above, or who just won't have Google Play Services. And my recommendation for that is make sure your styling is not dependent on your custom fonts, and that you're using text style equal to bold, text style equal to italic, and not just using lato italic, lato bold, because those users will just see a bunch of unstyled text. So make sure to use styles, and they will see Roboto, they will still see your system font. So up to your app demographics, if you're okay with these users having not seeing your custom font. Of course, it's not the support library without its crashes. There is a crash in 27.02, which has to do with launching your app under lower internet connectivity. So if you're going down the upgrade path right now, this would be a good one to skip. The versions before and after work fine. So when you use resources compat.getFont, a resources not found exception can be thrown because your font may not have been downloaded yet. And so this is a case you have to handle. What I do is I program, if I care about this case, I programmatically get it if this exception is thrown. And if you're using custom font that is not a Google font, then you're going to have to write your own font provider to load the font, and there's no public, official documentation on this, although Twitter figured it out and was able to implement Twemoji by writing the custom font provider. So it's something you could do, but not the most straightforward thing. And fonts are extremely persistent once downloaded, which is great for the user, but kind of annoying as a developer, because if you want to retest the download, you have to have access to a rooted phone, you have to go there, you have to delete the font files, you have to clear Google Play cache, you have to clear your app name, app cache, delete all your data, because in some versions of Android, it copies it into your app space, and then you can retest the download. So you can have fun with that if you like. And yeah, more reading. And the next topic is Emoji-compat, which can also work with downloadable fonts and makes use of fonts. And who doesn't love emojis, right? So Emoji-compat essentially avoids us from seeing the squares of sadness that you see when you don't see the emoji. When your app can't render an emoji, it shows you this tofu, and it's really sad when you see it. Was your friend being sarcastic? Was your friend being mean? Was your friend being happy? You'll never know. It can lead to a lot of miscommunication, and Emoji-compat is here to help you. Why do we need it? Well, now Android users do not need to upgrade their operating system in order to see the latest emojis, which is great because we know that Android folks are not great at updating their operating systems, or they sometimes can't because of the hardware. And so now users up to API 19 can see the fixed hamburger and beer emoji on Android, where the cheese is now above the meat and not below, and the beer emoji is not defying physics anymore, like there's no random vacuum between it. And so now users up to API 19 can see this new emoji, and apparently this was so important that Sundar Pichai, he opened the Google I/O keynote with this announcement. So people care about this stuff apparently. So, yay, Emoji-compat. So how does it work? Emojis are represented by Unicode code points, and Emoji-compat essentially scans through the text, it finds the Unicode code points that represent emojis, and it checks to see if the system can render it. If it can, great. If it can't, then it replaces it with an emoji span. An emoji span is nothing but a replacement span, which can replace certain care sequences with customizations. And so this emoji span contains a reference to an emoji metadata object, and that can render glyphs using the support font. So it is because of this support font and this replacement technique that Emoji-compat can render the latest emojis on older versions of Android, which is pretty cool. So how do we use it? You can use it using downloadable fonts. Put in the dependencies. The first one is for regular widgets. The second one is if you use AppCompat widgets. Set up the font request like you've seen before, except that the font here that you're requesting is the support font, in this case, Autocolor Emoji-compat, which can render the latest emojis for Android. And then you can set up a font request Emoji-compat config object with the onInitialize and onFailed callbacks. And then you call Emoji-compat.init with this config object. And you want this to happen as soon as possible in your app's lifecycle, so I put this in the application class, and that's worked pretty well. And just as we saw preloading for fonts, downloadable fonts, there's also preloading for Emoji-compat. There's this handy font provider requests tag that you can put in your manifest, and that Google Play services will read at both update and install time. And it initiates the support font download at that point. So by the time you load your app, hopefully you're not seeing 5 seconds of tofu followed by suddenly an emoji. Again, not a guarantee this won't happen, but this reduces the likelihood by a lot. And another way to use Emoji-compat is through bundle fonts. And this essentially bundles the support font into your app. You call bundled Emoji-compat config, and there is a set replace all property that you can also use with the downloadable fonts config. And this property is pretty cool because it essentially tells EmojiCompat to use the support font to render every single emoji. So what this results in is consistent looking emojis across devices. So if you don't want your users to see ugly Samsung emojis, they don't have to. You can use this and they'll have a consistent emoji experience. One thing to note though, if you're using bundle fonts config, it will load your APK, it will add around 7 MB per font, and your users will have to upgrade your app at least once a year to get the latest emoji. However, it is not dependent on Google Play services, and you can use things like set replace all. So do what's best for your users and your app. So how do you use EmojiCompat after configuring it? There are widgets that work out of the box, namely text view, edit text, and emoji button, and their AppCompat variants. But what if you're working with a widget that is not one of these? You are not out of luck. What you can do is listen to when EmojiCompat is initialized, and if it's sort of initialized, this callback will happen immediately, and then you can call EmojiCompat.get.process, which will put the text through the whole replacement technique that I talked about earlier. And this way, even text input edit text can render emojis. So that's pretty cool. One thing though, only widgets that can render spanned instances. This only works for those widgets. All right, last slide. What are the gotchas? It's APN 19+, but if you're supporting versions below that, it's fine. It's just the widgets will behave normally, as if EmojiCompat didn't exist on versions below that. The process method I just showed only works on widgets that can render spanned instances. So for example, it worked on the text input edit text, but it won't work on the hint of a text input edit text. So something to keep in mind. Make sure to handle the failure cases. So when I was working on it, some of the code samples I saw set the text in non-initialized and didn't do anything on failed. Well, seeing tofus is better than seeing no text at all. So make sure to set your text either way, or just to handle it. And if you're using EmojiCompat with downloadable fonts, then all of its gotchas apply, like being dependent on Google Play services and such. And more reading. And that wraps up this talk. I hope you'll take advantage of features like downloadable fonts and EmojiCompat. The more apps that use it, the more memory, disk space, data you'll save the user. Remember the sunshine and rainbows, like that's what the end goal is for our users. And if you have any questions, I'll be hanging around after, so feel free to ask me, and that's my Twitter if you want to get in touch. Thank you to the organizers for having me. Thank you so much for being here, and enjoy the rest of your conference.